the half. So it's always 1 over that number, the reciprocal of that number. And see here, our sine function always goes from 0 to 2 pi. Okay, so if we compare the original, it's going from 0 to 2 pi, and that's 1 full cycle of sine. Here, going 0 to 2 pi, it's 1 full cycle of sine, just a little bit taller here. So now, when we go to 2 pi, we see 2 full cycles. So there's 1 cycle in yellow, and here's the second cycle of pi. So this is 2 cycles in the same interval because we are shrinking it horizontally. And again, you can always double check these in the graphing calculator. And the rules are written out for us here. Let's talk about some examples. So these equations have a lot of transformations to them. So here we have y equals -3, absolute value of -2 times x plus 1, closed absolute value -4. Okay, so there's a lot going on here. So let's break this down. So first, I think we should note that the parent function here is y equals absolute value of x. That's the parent function here that we have. We have an absolute value function. So everything else is just a transformation of that function. So let's start off. If we have a negative all the way in the front, remember that's a type of reflection over the x-axis. A negative in front is a vertical reflection over the x-axis. That 3 in front, that's a dilation. The factor is 3. The factor is the same when it's in front. And then inside our absolute value here, this is where we're talking about the inside of the function. Everything here is inside. The rest is outside. So this stuff is outside. So the inside of our function has a negative in front. That negative means a reflection over the y-axis. So the negative in front was a reflection over the x. The negative inside is a reflection over the y. That 2 is giving us another dilation, but instead of the factor being 2, it's 1 over that number. So 1 over 2 is our dilation factor. It's shrinking it. That x plus 1 in parentheses here, that plus 1 in the parentheses, remember that's left and right when it's plus or minus inside the function. And plus, you might think more to the right side, but it's actually more to the left side. We're going more towards the negative side. We're going to the left. And then all the way outside of our function, we have a -4. So a plus or minus at the end is up or down, and minus tells us it's down. Okay. So the inside part is the shift of the x. So remember our factor was actually 1/2. So the x is going from x, whatever it is. So let's say we start off at 0. If you wanted to find like where the point 0, 0 shifted, you would plug in, let's say we want to find, I have it written down here. So let's say we want to find where 0, 0 shifted. You would plug in 0 in for x, which would just give us -1. So 0 goes to -1 here. So the way that this transforms is -1/2 times x minus 1. The x is being affected by the inside. The y is the stuff affected by the outside. So that stuff, it's just -3 y minus 4, which is just the outside stuff. -3 times y minus 4. So if we wanted to see where 0 went, you would plug in 0 for y, which would just spit out -4. So the point 0, 0, the origin of absolute value of x, our new origin would be the point -1, -4, which is here. So you can just do that for more points on the original and then plot them to get a sketch of the transform function. So here is the transform function. We could call it y prime, whatever. Okay, it comes easier with a little bit of practice. So same idea here. I would just kind of try to take note of this stuff, start memorizing these rules. The negative in front here, reflection over an x-axis. First off, I guess I should back up. Our parent function here is y equals square root of x here. We have a 2 in front. Remember, in front, a whole number in front is a dilation factor of 2, factor of itself. And then outside of our function is a plus 3. So that tells us we're going up 3. So that's the outside stuff, which means our y value is being shifted negative 2y plus 3. Okay. Then our inside stuff, we have a negative in front of everything. That is going to be a reflection over the y-axis. We have a dilation of a half. So that's going to tell us that the dilation factor is 2. Right? It's like that thing upside down. And then the x plus 1 tells us that we're going to the left one. So all that inside stuff affects the x value. So the x value is being affected by negative 2x minus 1. So you kind of distribute that negative in and flip the dilation factor. And then let's say